Record. And we're good to go. Okay, so everybody, I would like to introduce you to our feature speaker for the night. Chuck Pierce works at, I believe, LinkedIn, right?
That's
and
right.
you're gonna be showing us about some really awesome CLI type stuff with Rust.
That is the plan, yes.
All right, well, none of you are here to listen to me talk, so I'm just gonna hand the floor over to you, Chuck, and take it away.
All right, let me share this. Looks like that's working. So, all right, thank you, Brooks, and thank you everyone for having me, coming at you from sunny California and not quite Denver, but that's the beauty of the internet these days. So today, I'm going to talk to you a little bit about how to build delightful CLI tools with Rust. So I'm going to talk a lot about sort of general concepts around CLI tools, but also how there are a number of different Rust crates that can help you with building out those tools and sort of meeting these goals. So it's kind of a combined talk between Rust specific things and then more general concepts that I've seen. So first, some introductions. I'm Chuck. I'm a staff engineer at LinkedIn, and I work on JavaScript tools. So I work on a bunch of tools that are used by our JavaScript developers to try and make them more productive and essentially do everything to get out of their way so that they can focus on the product work that they're doing. And a big piece of that is I'm the lead maintainer of Volta, which is a toolchain manager for JavaScript that's written entirely in Rust. So we picked Rust for a number of reasons. The big one, one of the big ones being that it's cross-platform. We can compile it to a native binary for Linux, Mac, and Windows and use the same code base, which is just one of the great advantages of Rust. Another piece of that is the way it works is it runs sort of on every command. So we wanted it to be as fast as possible so that the users don't really notice that we're running. And Rust gives us that speed as well as being very high level and kind of, we can be really productive in it. So with Volta, we sort of focused on it making the developer experience as delightful as we could. And based on the feedback from that, we really learned a lot about how to build CLI tools. So the sort of theme of my talk today is really focus on the user experience. A lot of times when CLI tools are built, people think, oh, well, there's no GUI, there's no Windows I have to deal with, there's no images on the screen. I don't really need to worry about the UI or the UX. And really, that's just not true. There's a lot of opportunity for design work and for making the experience better for your users. And one of the first ways to do that really is to make sure that whatever you're building, you're also a user of yourself, so that when you have pain points, you can see, oh yeah, that is frustrating, and you can immediately start to improve on it and make it better. This obviously isn't there's no perfect result. It's always a process of continuous improvement. So the first piece to think about is sort of the first impressions. What is somebody going to see when they use your tool? Well, the first thing someone does with the CLI tool is generally they run it. So you need to have the ability to show some help and also some way to understand what the user is trying to do. So for that, we need to parse arguments. And pretty much, any tool of decent size, other than something that's really one-off and very specific, needs to have some sort of arguments, even if it's just an output file or an input file or something like that. And we need to parse those arguments in a way that we can then use it within our app. And so in Rust for that, the clap crate, which I believe is an acronym for command line argument parser, is really the standard. Pretty much every Rust CLI I've seen uses clap in some way. And I've got a link here to their website, and it really is very robust. It provides a lot of things. It does the parsing of the arguments, but it also will detect if there's an error based on how you've defined the possible arguments. If somebody puts something in that doesn't fit or doesn't parse, it will show them an error saying, hey, this argument was incorrect. It also automatically will create help, a help option for you. So the user types, my command --help, it will show them the usage and everything like that. And you can set settings in there to make it be very color, you can color it in the terminal or things like that. However, the problem with clap is that there's a lot of boilerplate. So I have an example. And this is straight from their docs. It's their first example. And you can see there's just a lot of these. This is only defining three possible flags and one subcommand, and it takes up this whole screen. And there's just a lot of these boilerplate that you have to write with clap. And so the next piece that I've found makes things better is a crate called struct_opt. And struct_opt is a wrapper, essentially. It's a derived macro for clap. So what it does is it lets you define a struct that represents your program. And then it will derive all of the stuff we saw on the previous page for that and allow you to work basically with a struct that just has, like in this example, a bool, an F64, a path buff, an option, and it has a lot of useful features. So one of them is that it will pull in the dot comments for each of these will be part of your CLI. So if you do a help, it'll show, debug, and then the description of that will be activate debug mode and things like that. So it can do that. It can do long and short flags. It can handle optional. It does a lot of these things out of the box. And then it also has the full power of clap behind it. So if you need to pass it some of the really obscure options, there are ways to do that as well. So struct_opt lets you do just a lot. And I've found anyways, it makes things a lot easier to understand what's going on. It lets your settings be declarative. They can, you just define sort of these are the data I expect to get from the user. And then the user runs the command and struct_opt does all its things. And then you get this object back that has all that data in it. And from what I've seen, they've actually planned to include this directly into clap version 3. So it will switch to being derived clap instead of derived struct_opt. And that's currently in beta. So that's your argument parsing and sort of that first impressions. The next thing is once the user tells you what they want you to do, you have to tell them what you're doing. And it can be frustrating when you're using a command, a CLI tool, when you type the command, you hit enter, and the terminal just sort of sits there. Is it working? Maybe. You don't know. There's no real feedback. So you want to give feedback to your users to let them know what you're doing. And if you're waiting for something or if you're calculating something or anything. And this can also really sort of make your tool seem a lot slower than it is, because if you don't give any feedback, the user might decide, oh, this could take hours. I'm going to context switch and switch over to my code editor and start doing something else. And then they come back whenever. And so it feels like it can really make things feel like they take longer. So for that, there's this trio of crates that I've found are really great for really making your output look cool. So the first one is indicative, which gives you progress bars and spinners in the terminal. And then console gives you coloring and padding and sort of looking at the width of the possible output. And dialogger is prompts. So if you need to ask the user for information, it can help you with that. And all three of these crates are written by the same author, and they're all connected, designed to work with one another. Another thing I did want to mention for console coloring specifically, which comes up a lot, there's also a crate called term color. And that one has a slightly different abstraction. What it does is it lets you, at the time that you're writing to the terminal, change the color, as opposed to at the time when you're generating the message. So it kind of depends on when you want to add color, whether you want it to be at the start or at the end, on which one you use. And I've got some ideas myself about how to kind of come up with something that lets you do both, but I still haven't totally figured out the API for that. Another piece with giving feedback is you don't want to overwhelm the users. If you put too much noise out there, people often will just ignore it. They'll realize, oh, this thing always spits out a bunch of information. I don't need to pay attention to it. And then when you spit out something that actually is important, they miss it because they're so trained to ignore it. So you should really make your default output only what's absolutely necessary. Things that, an error, something went wrong. We should definitely show that to the user, but try not to spit out a bunch of stuff. And where possible, you can give an option or multiple options to sort of increase the amount of information if the user needs to debug or something, a verbose flag or something like that. And we actually had a long debate within Volta, the tool that I work on, over whether we should even support showing a warning to the user, because it's so easy for those to become common and then be ignored. And we ultimately did decide to add them, but we use them very sparingly. We don't spit out a lot of warnings. So with that, we need to have logging. We need to be able to have different levels of logging. The sort of typical command line ones are error, warning, log, debug, and trace. And these are different levels that the user can subscribe to, whether based on how much they want to, how much information they want to get. And for that, the standard thing that I've seen is a crate called log. And what this crate does is it provides you with a bunch of different macros named after each of the log levels. And these macros work exactly like the print line macros or the format macro. So you provide it with a format string and then parameters, and that will get logged to the appropriate error or the appropriate level. And then based on how you set them up, it also provides loggers, specific implementations of these that will connect to those macros and output whatever it is the user wanted. So there's one that will pull the log level from the environment, from an environment variable. There's one where you have to set it explicitly and things like that. The real big awesome feature about this is that you can use the log crate even in like a library without specifying the logger. So if your library uses the log macros, then if somebody later on in their CLI tool uses log for their output, they can sign up to get the messages from your library, even though you never wrote it knowing, or you had no idea when you wrote it what specific logger they were going to use. Okay, so that's sort of our output. We've learned what the user wants us to do. We're telling them what we're doing and what we found. So now we have to deal with errors. So obviously we want to write our CLI tool to be we want it to work. We don't want to expect errors, but so we want to minimize the chances that something goes wrong. But regardless, there's always going to be things that go wrong, whether it's the user typed in the wrong command, or the network is down, or the hard drive fails. There's so many different possible things. Errors are always going to happen. And you want to make sure that the error path and the error messages that your tool provides aren't overlooked. They should be an important piece. So far too often we've seen, that error messages can just be this like cryptic thing that you have no idea what it means, and you have to Google the exact phrase and hope someone else has run into it. An example of this is a lot of compilers. They just give you this very, unexpected token semicolon or something like that. And it doesn't help you because you're just like, I don't really know what that means until you get used to it. But errors are when your users are the most frustrated. They type their command, they expected everything to work, and it didn't work. So and if you have a bad or confusing error messages, that just makes things even worse for them. So really, that's another example of really thinking about the user experience. When the error messages aren't helpful, it just sort of compounds on everything. And your error message is really an opportunity to help the user and make the experience better. I wrote a blog post about Volta, about our experience with Volta, talking about how every error message is sort of a help screen in disguise. The user, something went wrong, we can tell the user what went wrong, but we can also provide context and a call to action or hints about how to fix it. A great example of this is the Rust compiler itself. This is one of the wonderful things about the language Rust, is that when you get a compiler error, a lot of times the compiler is able to say, hey, this went wrong, and here's why. It'll point you at the specific line, even if it's an unrelated line. It's able to figure out a lot of times, sort of, you borrowed this here immutably, and then now you're trying to borrow it mutably, and you can't do that because that's the rules of Rust. And it's able to point these things out to you and do a great job of giving you error messages. So related to this is we need to be able to handle errors in our app. so are in our tool. Rust itself provides the logic or the result enum, which is just great support for errors, and then the question mark operator that lets you sort of propagate them to where they need to go. The tricky part is when is generating errors. And for that, I don't really have a great recommendation here. There's a lot of different crates. I listed some of them here: snafu, anyhow, error, this error. All of these provide ways for you to create an error type and specify what information gets built into it, but also what information gets attached to it. So when we're showing an error to the user, we want to give some context, not just file not found, but what file wasn't found, why were we even looking for that file, that kind of thing. And these crates, each in their own different ways, give you the ability to build up error messages or build up errors out of other errors and combine them by adding context and adding more information about what happened. I also added a link here to, there's a Rust project that for error handling where they're really trying to normalize and really kind of decide on a way forward on this, because there is a lot of fracturing in the ecosystem around errors. Okay, so we also have some other considerations. We've shown the users, the user asked us to do something, we did it, maybe we had an error, maybe we didn't. But as we talked about at the beginning, or as we talked about when we got to errors, ultimately we don't want our tool to error. We want things to work. So we need to do testing. We should test it, and we should really have tests at in a bunch of different scenarios. We should test the happy path where everything works and make sure that it does the right thing. We should also test the error paths and really make sure that we're showing the right error messages at the right times. We can have tests at different levels of specific tests. We can have the unit tests sort of inline in the modules. Rust provides great support for that. Acceptance tests, again, Rust really helps here. And then depending on what our tool does, maybe even end-to-end tests where we actually interact with the API or the network that we're doing. And for all of these, or at least for the last two, and specifically, the assert CMD crate provides a bunch of helpful utilities for running tests. So it gives you the ability to locate the binaries. So instead of having to figure out where in your target/debug/whatever directory on your file system, the crate will find a binary for you. You just have to give it the name. And then it also gives you arguments for, or a nice structure, a nice API for adding arguments, adding environment variables, asserting against the return code, asserting against the output. So it really makes it easy to write tests that really just rigorously test all the different features of your CLI app. So beyond testing and having a help output, we also should have some documentation. That's super useful for people who want to dig in a little deeper than just the surface level and really try to understand what's going on. And a lot of times there's some sort of mental model that you have about how your tool works or what it's doing, and you can use your docs as an example to teach that model. And for this, one of the best things I've found is just really the Rust doc, the doc comments and doc tests. They can, it sort of does everything for you. It compiles it all into a nice website, and the doc tests allow you to write code blocks that you can be sure will then be run whenever your tests are run to make sure that they still compile and they still run and do what you expect. And the last thing I wanted to touch on is configuration. So if your tool is complicated enough, you might have some configuration settings. You might want to let the user tell you, oh, I want all my files to go into this folder, or, I need to use an internal network for something, so I need to go through this proxy, things like that. And it's great to to support some sort of configuration file. And I've found the best thing for that is to pick a format that's common in whatever space you work in. So if you're building a tool for other Rust developers, maybe use TOML, because TOML is a very common Rust thing. If you're building a tool for JavaScript developers, probably use JSON, because JavaScript developers are used to working with JSON. If you're building a tool for infrastructure as a service, that kind of thing, maybe consider YAML, because that's just sort of the common tool. And for all of these configuration formats, SERD is the gold standard in Rust for parsing. It's really a bunch of related modules that allow you to parse things in almost a plug and play. You know, for parsing JSON, you can just bring in the SERD JSON crate and tell it to parse. And SERD itself provides a bunch of derived macros for structs and things like that, where they just make it very, very easy and a very low boilerplate to do parsing into Rust data types. If you need a little more power on your configuration itself, there's a crate called config, and that gives you a bunch of customizability. It allows you to pull from a file, multiple files, or even pull from the environment variables and sort of squish them together and that kind of thing. And so that's config. All right. So to sort of sum it all up, Rust is a great tool for Rust is a great language for CLI tools, because it's fast, it's cross-platform. It's really just, it's amazing how productive you can be. All these helper crates that I talked about are allow you to work at a high level, even though you're working in a low-level systems language. And I've been working on Rust with Volta for a little over 2 years, and I'm continue to be amazed at how productive I can be working in a language that's this fast. And finally, when you're building a CLI tool, focus on the user experience. Don't fall into the trap of thinking that just because it's a CLI tool, I don't have to think about that. You know, really try to see the world from the perspective of your users and do things to make the experience better. One of the best compliments we've ever gotten on Volta, and I think I might have mentioned this, is that our users oftentimes will forget they're using it. It's so fast and seamless that they don't even notice that they're using it. And I think that was one of our design goals, is to be unobtrusive. And Rust and all these amazing helper crates have allowed us to really achieve that. All right. Any questions?
I have one.
Yeah.
As I face is my tool requires you to input a decent amount of information, and it can make typing things out fairly long. It doesn't feel like it's a good user experience, and I'm not sure how I would go about fixing it.
Interesting. Yeah, that can be, is it, I mean, if all the information is necessary, there's kind of a limit. The one thing I can think of, but I don't know if I have a crate off the top of my head that would help with that, would be some sort of autocomplete.
Alrighty. Yeah, no, the crate I've been working on basically saves articles, but like to do that, you need to enter the name of the article, the URL, stuff like that. And so I think that might be more of a case of maybe use a actual UI instead of a command line interface.
That could be a way to do it too. And it may even just be that the UI is very thin and just sort of calls the command line interface with a bunch of pre-formatted flags. That's one way to still have the CLI for people who want that, but also give a UI on top of it if that's a better experience.
Yeah, no, right now I have it like using SERD, like it's a CLI daemon pair. So it uses SERD to serialize the command, sends the command off to the daemon. And what I was thinking was more along the lines of maybe making some type of like a Chrome extension that talks to the daemon too.
Yeah, that's when you mentioned sort of saving articles, that actually was my thought too, is a browser extension so then it becomes kind of a one-click save this kind of thing.
One other option to consider there is like a terminal UI. So you could still stay in a terminal environment, but you could do really basic graphical things like an input form, and you could have like tabbing to focus between different input fields. And you could do that. I know there's one program, a Rust program called Finda, that is a combination of Rust and Electron And it also has browser integration and sending messages between these components for really fast. And it's kind of like a Alfred or Spotlight style heads up display where you type and filter and find like files and programs and bookmarks. So you could study that for how to like wire everything together with like a core Rust for really fast like searching, like the main bit of the work of your program in Rust, but you have to like integrate into a desktop environment that has all these other things. So that'd be another thing to look into, I think.
Thank you.
Definitely.
Chuck, I guess one question, do you have any recommendations for crates that control like UI, or what are your thoughts on UI in the terminal?
You know, I haven't like a terminal UI kind of thing, or sort of taking control of the mouse.
Yeah, I guess actually like a terminal, because I've seen a lot of those like older style apps, but also even new terminal UIs. They can look really good.
Yeah, I think definitely that's, and we sort of touched on that with the follow up in the last question. I do think I don't have any direct suggestions for that. I know sort of curses is the C standard, and I see there's at least a thin wrapper library around it in Rust, but I don't have a lot of experience there. I think one thing to consider if you're looking at that is it becomes a lot harder to be cross-platform, because the specifically the Windows terminals or the Windows shells are very different from the sort of POSIX, Bash, and Z shell and those kind of things that you find on Mac and Linux. So it can be kind of tricky to build something that looks the same in every environment.
Awesome, thank you.
Hey, Chuck, I just wanted to ask, well, first, thanks for the presentation. When I was first starting writing some CLI stuff in Rust, I ran into like some usability bumps where I was like trying to do cargo run to invoke my command line thing and pass some arguments, and just like had to bang my head against the desk to figure out that cargo expects you to give like a double dash before you can pass your actual binary, any input. Were there anything like that you kind of found along the way that might be helpful to share here?
I've found for myself, at least, if your arguments that you're passing are only basically aren't marked, don't look like flags, if they don't have dashes in them, then you can actually use cargo run without the double dash. You can kind of do cargo run binary name and then just attach the arguments. Other than that, not really, apart from in the testing side, kind of the assert CMD crate, which lets you kind of define them that way. But yeah, the run, and there's also can be, depending on how you organize your project, running the cargo test. Sometimes you might need to pass flags that say, hey, don't actually hit the network, and things like that, or feature flags, and that can get kind of tricky. It'd be nice if there was a way to set some like default testing flags.
Cool. What about like build infrastructure for doing cross compilation? Have you found there's any? I'm interested to know like what you guys use, if you're able to share.
Yeah, actually, like
hosting CI and stuff like that.
Yeah, it's all Volta itself is a public or open source project, and we just use GitHub Actions for everything. And we found the actual sort of Rust provided the Actions RS actions are great for that. They make it really easy to set up the environment. And in fact, I think we're actually even using cross compilation right now, because at least the last time I looked, GitHub Actions didn't have hardware for the new M1 Max. So we're doing cross compilation with Cargo cross, and that's all just provided by the GitHub Actions.
Gotcha. Cool. Good to know.
We have a question from Twitch. Josh Finney asks, is there an easy way to have a user configuration files for cross-platform CLI tools?
Interesting. I mean, I think the config crate, well, one piece of that is, picking a file format that is easily usable in any of them. I'm actually curious. I thought that the config crate would do that. Let me double check that that's the case.
He clarified how to find out where to place the config files.
Ah, okay. Yeah, so that's tricky. I feel like on Windows, there kind of is a general place. It's the local app data is very commonly the thing. On Unix, it's kind of a wild west. There's the XDG spec specifies in the .config, the home directory.config, but a lot of people don't follow that, and often they wind up in home directory / .tool name. So I don't know that there's a clear, this is the right answer for that. I think you kind of have to look at what other tools do. And, like I mentioned, the XDG spec, if that's something you want to follow, then that does give you some prescriptive answers. But there's really not a definitive, this is the way that everybody follows.
Tanaka 91 actually just responded saying directories -next might be a good crate for that.
Okay. Oh yeah. I think that actually has some of the XDG stuff sort of built in and things like that, or some decisions on there.
There's another question in a Zoom chat from Devin. Do you have any recommended mock crates?
I feel like we did use something, and now I don't. We generally don't do a lot of mocking of things. The one thing we do use is Mockito for mocking the network. And that lets you really very easily set up if the user, if this URL is requested, respond with this and that kind of thing. Beyond that, I think that you probably don't want to be doing a lot of mocking of sort of pieces. And I think Rust isn't great at providing like mocking just because of the way structs are.
Thank you. Does anybody else have any questions?
I actually have a question for you. Is there somewhere I can send these slides so that the different recommendations so people can find them?
Yes, probably the easiest way would be like on the Meetup page. Like you could put a comment on that Meetup page, and then I'm going to link to that Meetup in the YouTube video. And I'll put a link in there for where that video is. And then everybody who is here right now, if you're not registered for tonight, I would recommend go and just register, put that link in your, get a link to the Meetup page, and you'll get that information then.
Okay, perfect.
All right. Well, I don't think we have any more questions tonight. Thank you so much, Chuck, for coming out. This was a great talk.
Well, thanks for having me. I hope it was helpful.
Absolutely. Very, very helpful. How do I full screen? There we go. All right. Well, as I said, we meet once per month or so. We don't have a specific day. So if you want those notifications, if you like this, follow us on the Meetup page and you'll get notifications for the next time they're going to have a talk. And as we said earlier, we'd love to have you speak here or just come and hang out with us. So with that, I'm going to call an end to it. As a super successful Meetup night. Thanks again, everyone, and especially Chuck.
Muted.
All right. Thanks everybody for coming out. Have a great rest of your night. I'll see you all next time.